C, all right, of the cosmic ray is equal to gamma C E minus beta C PZ, so this is cosmic ray times C. Now we're just going to invert this guy, so it's just going to be basically E of the cosmic ray prime is equal to gamma C E of the cosmic ray C prime. That's right. And the only difference is this plus sign. Beta C PZ C R prime times C. Okay, so that's the new boost. So this is like boost into the lab frame. And let's basically calculate what the difference between these two energies are. All right. So let's calculate. So calculate delta E over E, right? Which is equal to E prime of the cosmic ray. Let me put these cosmic rays. Minus E of the cosmic ray divided by E of the cosmic ray. Okay, now I hope this is gonna work. All right, but we'll find. We'll know in a second. All right. Okay, so let's do this. Let's plug in what this guy is. All right, so that's just going to be gamma C E cosmic ray C prime. So that's just this guy right here. Okay, plus beta C PZ cosmic ray C. Okay, minus ECR over ECR. Okay. All right. So now let's plug in what. Oh my God! I hope this works. It's going to work. Okay. Here's why it's going to work. Okay. So now I need one more piece of information here. Okay. So I just don't start on the edge of it. Jeez. Okay. So PZ is equal to what the heck was it again? It was basically beta of the cosmic ray. All right, E of the cosmic ray over C. Okay. Times the cosine of theta. Right, okay. And PZ prime. God, I really hope I did this right. Yeah, I think I did this right. Okay. This is going to be equal to beta of the cosmic ray, ECR of the cosmic ray over C prime, okay, cosine theta prime. Right. Now I'm going to do something here which is not totally kosher, right? But you're going to forgive me if I do so. And I'm going to basically say that that this is C prime in the cloud frame is just that. Now, the reason why it's not totally kosher is that you probably remember like relativistic aberration, all right? Namely that the angle theta prime in the lab frame is not the same angle theta prime in the booster frame, right? But I'm going to take it on faith that this is going to be an order basically beta cloud squared correction, all right? Okay, so let's basically finish this off now. All right, so this guy, let me just move up a little bit. Delta ECR over ECR. Well, this is going to be equal to gamma C ECR C prime. Okay, of basically 1 plus beta c cosine theta prime. Okay, the c's will cancel out this c, and then the EC can be pushed out to the front. Okay, over ECR, and instead of basically divide minus ECR, just basically minus 1. Okay, just divide it out by ECR on that side. Okay, so now let's plug in what we know for ECR, which is just basically we know that this guy right here, ECR C prime, is equal to ECR C. This is what elastic collisions mean. And we can plug in what we know for EC, which is this equation right here. Okay, so let's finish this thing off. I've been saying this for a while now, but you better believe me. Delta ECR over ECR is equal to gamma C. Now this guy is going to be basically ECR, okay, of 1 minus beta C cosine theta, right? That's just this term for ECR prime, okay? And now I need to plug in this part right here, 1 plus beta C cosine theta prime, okay, over ECR minus 1. Okay, now lo and behold, this kills that thing, and then we're just left with this guy. So let's compute this guy out. Okay, so delta E CR over E CR is equal to okay, so there's hold on, did I miss the extra factor gamma there? Let's just go back there and check it out. And oh, you guys, let me skip by with this. There's a factor of gamma here and another factor of gamma there. So this in fact should be gamma squared. Okay, so now let's calculate this thing out. Okay, so now this is going to be equal to gamma C squared, all right, 1 minus beta C cosine theta, 1 plus beta cosine theta prime, okay, divided by EC whatever, but that's kind of minus 1. Okay, so that's my answer right there. And now if I compute this guy out, just by multiplying out, this is just going to be equal to, let's see, so, did I screw up something? No, I think this is fine. Oh, actually, in fact, I got the right answer this time. Let me just make sure I understand something here. 1/3, 1/3. Okay, well, okay, so let's just finish this thing off, basically. This is going to be equal to 1 gamma C squared, which is, there it is, 1 over 1 minus beta C squared. That's just this guy right there. Okay, times 1. Okay, so 1 times 1 is 1 minus beta C cosine theta plus beta C cosine theta prime minus beta C squared cosine theta prime. Okay? Right. Now, you may think, okay, that is now okay to basically kill these guys off, all right? But that is actually not the case, right? In fact, we have to keep all the beta squared terms, and the reason why will become obvious in 1 second, right? Okay, so the distribution right, of cosmic rays is isotropic in the quote-unquote lab frame, okay, which is where the cosmic ray is moving to, right? Okay, is also isotropic for the scattered cosmic rays in the cloud frame. Okay. So what I'm saying here is that, like, in the lab frame, the cosmic rays have lots of time to scatter, so it's going to get isotropic distribution. We're assuming that once they get scattered in the cloud, they're now isotropic in the cloud frame as well, right? Now, because these two frames are not equal to each other, you will get basically an extra effect there, right? Okay, so what this means that in the lab frame, the rate of collision is gamma, which is the rate of collisions here, okay, is equal to n sigma v, okay? And because of the fact that we're moving relative to these cosmic rays, this means that for the cloud, the rate of collision is that basically it goes to n sigma of c plus or minus v cosine theta, right? This is the extra fact to the cloud is actually moving with respect to the cosmic ray. Yeah, okay. And this cosine theta denotes the angle of the cloud's direction relative to the cosmic ray, right? So if I look for the average angle that a cosmic ray scatters or collides with the cloud. So this is not the scattered cosmic rays, which are isotropic in their frame. This is in fact the cosmic rays which haven't been scattered yet. Okay, if I do that, let's basically compute what that has to look like. Okay, so I'm going to define an averaging quantity. So define an average value x as a scattering over all the scatterers possible is equal to 1 over 4 pi, okay, integral of x d x gamma d omega divided by 1 over 4 pi integral of gamma d omega. So this is basically averaging over all possible scatters. And so this might be, you might think of this as the averaging scattering rate, average scattering rate. And this might be the scattering weighted average. Okay, that looks beautiful, right? So let's just finish this off now. I'm going to try to calculate what the cosine of theta gamma has to be. Well, this is going to be equal to, okay, the 1 over 4 pi, okay, integral cosine theta, okay, of gamma, right? Which in this case is just this term up here, so I'm going to just basically pick one of these guys. 1 plus beta cosine theta n sigma c, alright? Okay, and then I'm going to integrate over d omega. So d omega, which is basically d cosine theta d phi, and then divide this by 1 over 4 pi integral of gamma, which is just basically 1 plus beta cosine theta n sigma c d cosine theta d phi. Alright, so this bottom part is pretty darn easy, alright, because of the cosine theta here, this term here will average out to 0, okay? Now, not so true in the top though, unfortunately, okay, because this extra cosine theta here, this term goes to 0, but this term actually stays there. Now, if beta had been 0, life would have been fine, basically, because this cosine theta would have been averaged over everything. This would have been 0 over basically something that's not 0, and this would be an average angle would have been cosine theta, which means that basically there's no preferred direction. That's all that really means. But now, because the cloud is moving, there is a preferred direction. In fact, if you were to calculate that, you basically see that because it has extra cosine squared here, right, I'll get extra preferred direction, which is of order. Let me see if I get this right now. It's going to be of order, I think, 1/3 beta. Okay. Basically, you could do this very simply. All right. By just noticing that this gives me a cosine squared, and my average cosine squared, I get 1/3 out, basically, out of that. Okay, so that's where that comes from. Okay, so this is our final answer. Now, basically, you will get the same result, all right? So you get the same result. For averaging the cosine theta prime over all gammas term as well. Okay. Let me just make sure you guys see that. Okay, so let's basically finish this off. We're almost at the end. Trust me, the pain will soon be over. Okay, so, yes. So, the averaging of delta E cosmic ray over E cosmic ray for all scatterings, right? Well, this is just going to be equal to what we had just calculated earlier, 1 minus beta C averaging cosine theta gamma, right, plus beta